Hello and welcome back. Today I'll be discussing the end of chapter problems for chapter 1 for the Cengage biochemistry. There are 5 problems, I think, and you may get them in a different order. So the first problem that I got is a 3-part problem here, and it's seems a bit challenging, but actually when you work it out, it's really not that difficult. So let's read the problem first, and then we'll work it out. So E. coli cells are about 1.8 micrometers long and 0.770 micrometers in diameter. How many E. coli cells laid end to end would fit across a pinhead of a half diameter? Second, we need to calculate the volume of an E. coli cell, assuming the cell to be cylindrical in shape. Okay? And then third, we're going to calculate the surface area and surface area to volume ratio of an E. coli cell. Alright, so let's start with the first part. How many E. coli cells laid end to end would fit across a pinhead a half millimeter in diameter? Okay, so let's go over to this PowerPoint in Edge so we can work it out. Okay, so we've got E. coli, so this is part 1. We've got E. coli being 1.80 micrometers long, and 0.770 micrometers in diameter. Okay, we'll draw that out in just a minute. And we're going to see how many will fit on the head of a pin that is a half millimeter wide if they're laid end to end. So what's the catch here? We're saying that these are rod-shaped or cylindrical shaped. So a cylinder looks like this, so we're going to assume they look like a cylinder. And the diameter all the way across here is 0.770 micrometers, and the length is 1.8. So we only care about how many will fit on the head of a pin. This is not to scale, of course. A half millimeter across. Okay, so we're going to lay these end to end, because they're cylinders. Okay, so notice that the only thing that matters here is the 1.8 micrometers long. Okay, so each of these are 1.8, and we just got to keep on going until we get to that half a millimeter. So we need to count. Okay, so let's do that calculation. So what we want are the number of E. coli per pinhead, right? All right, and so that looks a little bit tricky, because it looks like we're going to put our E. coli on the top and our pinhead on the bottom, but actually what we're going to do is say that if our pinhead is 0.5 millimeters, okay, per pinhead, okay, and then we're going to put the length of the E. coli cell on the bottom, 1.80 micrometers per E. coli. Okay, so what does that do? That brings this, when we work out this fraction, okay, that's going to bring our E. coli back to the top, okay, and our pinhead is going to go to the bottom, and that's going to give us E. coli per pinhead. So that's kind of the trick to this problem. Everything else is just very straightforward. So first we want to convert to standard units, okay? And so let's put these in meters. So a half a millimeter is 0.5 times 10 to the minus 3, because a millimeter is a minus 3 meter in meters, okay? And that's per pinhead. And on the bottom we've got 1.80 micrometers is 10 to the 6th times 10 to the negative 6, meters per E. coli. So each E. coli is 1.80 times 10 to the negative 6 meters. Okay, the meters cancels. The E. coli is going to come back to the top, and the pinhead is going to go to the bottom. And so that is going to be 277.7 E. coli per pinhead. Okay, so that's part 1. Ah, shoot. Can I undo that? Oh, no, that's not what I wanted to do. Lovely. Okay, let me erase this little... There we go. Okay, so I'm going to do part 2. There we go. Now we got it. So for part 2, the question is... let's go back to our question here. Calculate the volume of an E. coli cell, assuming the cell to be cylindrical in shape. So the volume of an E. coli is equal to pi r squared height. Okay, for a cylinder. So if we got a cylinder here, then our height is this, and the radius is half across the bottom, right? Pi r squared times the height. So the volume is equal to pi, so that's, well, we could just go ahead and write in. I used 3.14159. I don't have a calculator right now. You can just use the button on your calculator if you got one. I had to use my phone. Left my calculator somewhere. Alright, and then the radius. Okay, the radius is half of the diameter. So remember, our diameter was D was equal to 0.770 micrometers. So if you divide that by 2, that gives us the radius. So the radius is 0.385, and we'll go ahead and convert that to meters, times 10 to the minus 6 meters. Okay, so that's 0.385 times 10 to the minus 6 meters squared times 1.8 times 10 to the minus 6 meters, and that was our height, which is the length of the E. coli cell. Okay, so this was just the length of the cell. That's our height. Okay, and so that is going to give us 8.382 times 10 to the minus 19 cubic meters. And that is a unit of volume. That is perfectly fine, but I don't think I think they want you to convert that to liters in order to put it into the space, okay? So in order to convert that to liters, we need to convert cubic meters to liters. So 1 cubic meter is equal to what? A meter is 100 centimeters, so 100 centimeters, and we'll cube that, okay? And that is equal to 1 times 10 to the 6, if you work that out, cubic centimeters, okay? And a cubic centimeter is equal to a milliliter. Okay, so 1 cubic centimeter is equal to 1 milliliter. So that is equal to 1 times 10 to the 6, or a million milliliters. Okay, so if you divide that by 1,000, you can convert it to liters. So that is equal to 1 times 10 to the 3rd liters. Okay, so that converts it to liters. I mean, that's our conversion factor for liters. So 1 cubic meter is equal to 1 times 10 to the 3rd liters. So we need to convert our answer to liters. So volume is equal to 8.382 times 10 to the minus 19 cubic meters. Okay, and 1 times 10 to the 3rd liters is 1 cubic meter, so cubic meters cancels, and that gives us 8.382 times 10 to the minus 16 liters. So you'll have to look at your sig figs. I think we had 3 sig figs. Look at your sig figs and put it in according to the number of significant figures that you had. So go back and look at, I think we had 3 actually. I think this was supposed to be a 0 behind it. Okay, so probably 8.38 times 10 to the minus 16 liters will be the correct answer. Alright, so the final question in that section, in that problem, okay, so part 3 for that problem was the surface area of a cylinder is, calculate the surface area and then surface area to volume. So calculate the surface area and surface area to volume ratio of an E. coli cell. Okay, so what is the surface area? Okay, now that is, I don't remember if they gave you the formula or not for that, but here is the formula for that. Alright, so surface area, okay, first, and then we need surface area divided by volume. So that'll give us the surface area to volume ratio. Okay, so first we got to calculate the surface area. I'll just abbreviate that as SA. So surface area is equal to 2 pi r squared plus 2 pi r h. Okay, so why is it equal to that? That is because pi r squared is the, okay, so let's look at this. Here's your cylinder. Okay, so the area of the cylinder, if we want to get all of this, so we're looking at surface area. So we need the area of this cylinder. Then we need the area of the top cylinder. So the area of the bottom cylinder, area of the top cylinder, and then the area of the outside. That gives us the surface area of the whole thing. Okay, so the area of the bottom cylinder is pi r squared. The area of the top cylinder is pi r squared. So that is 2 times pi r squared. That gives us the top and the bottom. The area of the outside of the rest of the cylinder is the circumference times the height. Okay, so that's 2 pi r times the height. And that will give us the surface area of the entire cylinder. Alright, and so the surface area then is equal to 2 times 3.14159, and I didn't put my numbers in. They may be using 3.14, so just, you may have to figure that out. 0.385 times 10 to the minus 6 meters, okay, is the radius. Remember, we calculated the radius, plus 2 times pi, which is 3.14159, okay, times the radius, which is 0.385 times 10 to the minus 6 meters, times the height, which is 1.80 times 10 to the minus 6. Okay, so if you work all of that out, so how are you going to do that? Make sure I got that in there right. I didn't square this. This is squared here, right? Right. And so if you square this, okay, then multiply times 3.14159, then multiply that times 2. I'll go ahead and write that down. That gives us 9.31, if I did this correctly. 324 times 10 to the minus 13 plus, and then you're going to multiply 2 times 3.14159 times this, and that gives you 2.419023, and I'm not doing sig figs here, times 10 to the minus 6. Okay, so notice that this is minus 13th, and this is minus 6th. So this number over here is practically negligible compared to this number. So the 2.419, you can go ahead and add it up, but the final answer is just going to be 2.419 times 10 to the minus 6. Okay, and so then our surface area to volume is going to be equal to, and that is meters squared, right? That should work out to meters squared. Okay, and so that is 2.419 times 10 to the minus 6 meters squared divided by 8.382 times 10 to the minus 19 meters cubed, and that should give you 2.88 times 10 to the 12th meters to the minus 1. Okay, so that should complete this particular problem in your end of chapter problems. I'm not sure which one it will be for you, but you will have different numbers, so best of luck.